So what's going on, Josh? I saw your tweet. I don't get it. I don't understand what you're doing.
All right, so this is data layer stuff. So this is just I've basically downloaded the Atari branch from Chia, and I've got it in a Docker container running. Got it set up with my blockchain database, so it's all synced.
But wait, there was some dead beef thing. What is this?
Yeah.
You tweeted dead beef, and it's like I looked at it and like I don't get it. What is going on here? What is dead beef, and what is this all about?
Yeah, so the tweet I put out was actually, if you look closely at it, it's me using the new CLI in the Atari build, which has a new data command, and it lets you actually interact with the data layer that we're talking about. So
this is the one you and I were fighting about, right?
Yeah, exactly.
The infamous infamous Twitter fight.
Yeah, and you said, hey, you should just prove it. And it's like, okay, well, I'll figure. Let me try to prove it. I don't know. So I've been kind of playing with it. And anyway, so what you saw on Twitter was the CLI arguments that I've played with, and it actually is storing via the new data layer RPC process. It's actually storing a key value pair. The key was dead beef, and the value was cafe food. These keys and values need to be in hex. That's the only reason they're.
These are some of my favorite hex values. So everybody that geeks out on hex. So hex is a way to encode things in computers. So it's hexadecimal, and each of these hexadecimal characters, when you do decimal, it's like 0 to 9, right? You have these numbers, these Arabic numerals. But then if you want to go more than 10, you have to have another letter or another symbol. So we use A, B, C, D, E, F. And then, so that's why you can spell these fun words like dead beef and cafe food, because you have up to F to sort of represent these other numbers. So actually when you have an F, it's 15 or whatever.
Right. And in cafe food, the O's, of course, don't exist in hex, so it's 0, 0. So, just make sure they understand that. So
these are these little fun programming jokes that like
when you like in grade school, when you put the 80085 on the calculator and turn it upside down. And same thing. We're all nerds here.
Yeah, exactly.
So anyway, so what I found, the tweet is that you can actually store this data into data layer. And once I saw that, if you look further, my next tweet was actually storing some bigger blocks into this thing called data layer. So the idea here, I believe, is to differentiate the data that's stored in data layer's database, which, by the way, it is a complete separate SQLite database, which we'll show you here in a second. There's data that goes into that, which is the actual data that we're storing, in this case, cafe food or this other big block that I stored. But the hash of that data then goes over onto the blockchain. So that's a much smaller bit of data, of course, and it goes into the singleton. That now, again, this is all terms that I'm kind of playing with in my head.
No. Let's break it down, because I think this is worth talking about it for a minute, because the blockchain, right, it's these coins and these coin spends, and we've all gotten kind of familiar with that. The thing about Chia, right, is we have this ability to create a thing called a singleton, right? And a singleton has a meaning in programming. It means a singular thing. Like there's a reason that it's prefixed with single and then ton. It's like, it means this one thing that exists as itself, and there is no other, and there can be only one. It's like Neo in the Matrix, right, man? It's like the one is a singular thing. And this singleton is something that we use in Chia when we do pooling, right? Because we create a singleton so that it can represent the place where we're farming to, right? And this singleton has this cool property that when you're part of a pool, the pool can reach in and claim coins out of it. Like that's the whole point of that thing, is like that you can pay to it. So it's a pay to singleton, and then the pool can reach in and grab stuff out. This singleton, this idea that exists inside of Chia, is being reused for a bunch of different things. It's being reused for DIDs. It's being used for NFTs. And it's also, I guess we're going to see that it's being used for data layer.
Yep, exactly. And so, and again, this is all kind of, just kind of guessing on my part, but what I'm kind of seeing here is when you commit some data to data layer, in this case, these simple little values, there's a hash that gets created for that data. And I'm not sure exactly how this all works yet, but somehow a hash of either that exact data or a hash of maybe the last 100 updates that you've done, or maybe there's a batch processing or something. There's a way that a hash eventually makes its way out into that singleton on the blockchain. And that's kind of an event that everybody else that's subscribed to your data store says, oh, there's some new data that I need to go sync now. And by the way, when I do sync it, it needs to match this hash, right?
I think I have an idea about how this works. So you have this database, right? And you put a bunch of data into it. And then what happens is you calculate a hash of that data, okay? And then to that point, you put that into the singleton. And then you put some more data in, and then you compute the next chunk. So it's starting from here. So I think there's like a mathematical property that says, if you start from here, you can calculate just the next chunk, and then that computes the next valid hash. So I don't think you have to start from the beginning of time and run it all the way forward. You just have to go to the last point that you calculated, and then you sort of hash this next chunk, and then this is the next hash that you can put in. And so that allows you to create the update set that you need to pass around. So if somebody said, hey, I'm way over here, then it would be like, oh, well, you need this chunk and this chunk and this chunk, and that'll get you up to date with the newer point that you're looking for.
And you know, that's a great point too, because a singleton, it's almost, if you, correct me if I'm wrong, but it's somewhat of a misnomer in that there's only one that exists at a time unspent on the blockchain. But if you're able to go back and look at the history of that singleton as it's been spent and recreated over time, right?
The way a singleton works is it reincarnates itself.
Exactly.
That's how, because otherwise a singleton would have very little utility, because it would sort of exist and it would be fixed in time. But what happens with the singleton is it allows itself to be reincarnated in another form with a slightly different form, but still being singular, and then having the ability to have some new stuff in it, some new data or whatever. And so you can keep reincarnating these singletons in new coins as you move forward. So yeah, you can totally chain it backwards and see the version history of the singleton.
Yes, exactly. And even as you're syncing forward, you would be able to verify, okay, I got that, that's good. I got that, that's good. You know, very similar to how, so you can sync in smaller bits with this. I assume that's the other thing. If you look at the data structure itself of the Datalayer database, it's very, and I'm not an expert in this, but there's definite Merkle tree stuff. There's left and rights and nodes and all this fun, these columns. It's not just key value. Those are two columns that get stored, but there's a lot of other columns that obviously are meant to find this data later and quickly get to it, right? Through binary
data layer later. I love it. Let's look at some code. I mean, I think we kind of looked at this just a bit, but I'm eager to get back into it again. Let's take a look. You're going to share your screen?
Absolutely.
All right. Cool. Okay, so you've got this super wide monitor. I think you told me about this, right? It's like it extends off 16 feet in both directions, and it fills your entire house. Is that right? So it's a little wide here.
This is my MacBook right here, but I'm looking all the way this way.
So I think one of the things we might need to do, so there's a hotkey in Visual Studio Code where you can, I think, shift Open Apple plus, and it will it'll zoom up your view a little bit.
Ah, nice. Okay. Whoa.
Hey, did you catch it? Like, you and I were both old fuckers, right? So you probably caught the reference. Did you catch it? The Apple IIe reference?
Oh, Open Apple.
Yeah. Yeah, because the command key, the what is it? The little.
I didn't even register in my brain because it was so natural. I was like, oh yeah.
I actually want to replace the key on my mechanical keyboard and get an Open Apple key, because like to me, that key, it will never be called command. It will always be called Open Apple.
Yep. Good stuff.
Okay, wait a minute. So let's set this up just a hair. So you did show me one thing which was kind of neat. You showed some Docker stuff. So I think we should do that one more time. So you're actually in the top level app, and I imagine you're going to publish this. But what we're looking at here is you've got a little project, this little Hello Atari thing, and this has a Docker Compose file. So the Docker Compose file, for those of you who aren't super familiar with this, it allows you to put together several Docker files. So as we're looking here on the right-hand side, scroll up just a bit, you'll see that there's this thing called services. So services lists off the different containers, and it allows you to name them. So we have two containers here, one called Hello Atari, and then we have another one called Chia. And then there's a bunch of programmer configuration stuff for each of these, right? And so this is configured in a particular way so that a Hello Atari and Chia can talk to each other in a network sense. So they're sharing a network, and they can talk to each other when they're doing a normal TCP or whatever types of networking type of operations, whether that be RPC calls or TCP/IP type stuff, and that's what you're seeing with these ports on 3000 and 8444 and all this stuff. So the Chia node here is running on port 84404. That's the standard port that when you're farming or working with Chia, that's the one that you see all the time in the UI.
Yep. Also, by the way, so this isn't something that I just came up with on my own. This is something you can go, this specific part right here came from the Chia Docker. So let me see if I can move this over here more centered so people don't have to crane their necks. But here in the Chia blockchain, the Chia network repositories, you'll find Chia Docker as one of the repos. And I'm not sure exactly where it is, but Chia Docker, there we go. So this is their example file of running a Chia in a Docker container. And it's really nice for just reference and all of this. They have some nice script files here, but I pretty much just kind of took out the, from the README file here, their examples for the compose stuff. And in this case, notice they're targeting Chia latest. So in this case, we're saying, go get me the latest stuff from GitHub, whatever it is. In my case, we'll move this out of the way again. You'll notice I'm actually targeting Atari. So if we go look at Chia, if you're not familiar with this, if we go look at the Chia blockchain itself, so here's the main Chia blockchain project. You can actually drop this down and search for different branches. So we're in main right now, which is the latest kind of thing that they commit to, that they're working on. But you can actually search here, and we'll search for Atari. Got lots of Atari stuff here, but I found that I think this is kind of the main one that they're working on. So if you click on that, you'll notice that there were actually 693 commits ahead and 102 commits behind. By the way, one of these is the version 2 database. It still uses the version 1 database. So I had to download my sharing database thing that I told you about. I still had to download an old version anyway. So anyway, I'll talk more about that in a minute. But it's a little bit behind of main, but they've also obviously added quite a bit here. And the main thing, if we go in and look at this code in this branch, is the Datalayer folder under Chia. So this is where you'll see a lot of the actual functionality of Datalayer, how it stores it. It creates a new wallet. So there's a new DL wallet that it creates in the wallet database for the Singleton. Got some different types here in the API, of course. You can also go see over in the RPC folder. You'll notice they've also added Datalayer RPC code as well. So that's good. And then finally, in commands. So this is your CLI. You'll notice that we've got Datalayer stuff in here as well.
It's the data.py one, right? I think that's what you're doing before.
Yep, you're right.
Yep.
Yep. Data and DB, I think. Oh no, that's the blockchain database. Yeah, I think it's data funcs. So anyway, now that we've kind of understood that, so I've got the actual project here, and this, I just call it Hello Atari. It's this simple Docker compose that's going to bring up a Node.js project. Right now, this doesn't have anything in it. This is just my idea to be able to figure out how to start interacting with Atari. So maybe I'll put up a simple list of tasks, like a Hello World type app. We'll do like a task list or something. Very simple. But its job is to talk to the Chia container over the RPC. So that's what this is for. And of course, it's targeting Atari. So once you get this up and running, what you can do is, let me just actually stop this. And actually, I don't know if I want to stop it. And yeah, if I stop it, this will.
No, don't stop it. Don't stop it. It's fine. Okay. Let's just do the same thing we did before.
So assume, yeah, this may be a separate video, but we'll assume that you've got this up and running. I'll certainly put some more README in the text.
Actually, just scroll down for a second. We'll shorthand what's going on here. So there's a full node that Josh has that's functional, right? So that full node is sitting somewhere and it's stopped at the moment, but it has a database which is very close to being synced. And then what we're going to do is we're going to start that Chia container with that database. So essentially what's happening here is we're mounting in the database file. So you can see this line 29, what we're doing here is this is what's called a volume mount inside of a Docker container. So we're saying something that is on my local system, I want that available inside the Docker container. And so I'm saying I want it to be available at a particular spot, and it just happens to be at root.chia mainnetdb. And what that will do is it will make it so that the database that is sitting there in the local file system that was synced using the normal Chia blockchain will be available inside the container so that we can do interactions on chain and do all the fun stuff. And so that's what we've got here is there are a bunch of volume mounts that are making all of this sort of interesting programming stuff available. And I had to do very similar things when I published the simulator, because I needed to do this kind of stuff, like make the SSL certs available externally.
Yep. Yeah, and if you don't do this, then of course it'll start up just fine, and it'll start syncing from zero, and you'll have to wait for 6 days or whatever it takes. So yeah, this just is kind of a shortcut to use your existing. Now, like I said, unfortunately, I've already upgraded my full node to the 1.3x, so I'm on the V2 database, so I save a lot of space. But the Atari branch, it looks like to me, is still using V1. I couldn't upgrade it, and even if I put in the config file a V2, it didn't like it. So obviously that's what it's behind on right now. They're still working on.
I was talking to Seth about this last night, and Seth Jenks, from the Chia Corp, and he started asking me some stuff. He said, what are your complaints about Chia? And one of the things that I said was, there are too many branches. And he goes, what do you mean? I said, well, this has got to be killing your guys' productivity because you have so many branches. And when things get committed to main, if you want to get up to date with main, you have to do this really difficult operation, which is called rebasing your branch. When you have all these branches that live for a super long period of time, every time there's a delivery to main, you have this cost on your branch. And you have to get it up to date. Well, what's happening on a lot of the branches is they're just like, I'm not going to deal with it. I'll just drift out of date. And here's a great example of another branch that has drifted out of date from main. And now we have this nightmare. It's like, as a developer, I want to play with Datalayer. Oh, I'm on the latest version. Oh, great. I can't. Like, this is untenable. It's just untenable.
Well, and to be fair too, there's literally no, this is all just me spelunking the code. So there's not even.
I know, but as a developer and you want to play with a new feature, it's like, hey, here's a new feature, and it doesn't work with latest. It's just, man, this is I don't know, it's a little rant, a tangent, but I think it's relevant.
The other thing you'll notice right here on the next line. So in this new version, there's another directory that gets created under mainnet called Datalayer, and so I also mapped that up to my host just so I can kind of interact with that Datalayer file easily. I can open it up in a DB Explorer and things like that, and just look at it without having to try to figure out how to do that all in the Docker container. And then this SSL stuff. So this is what we were talking about. We won't explain this too much, but when I do get this Node.js app up and running that will eventually talk to Datalayer, it will need to have the SSL certificates to be able to talk to the RPC endpoint. So we're basically just sharing the directories between the two containers with this little trick.
Cool. Well, no more of this setup stuff, man. Let's get to the meat. Let's see that happen. I think you've got a Docker extension installed in VS Code. Is that what the little whale with the ship on it is? Is that what we got going on here?
That's exactly right. So the cool thing is, so if you have Docker desktop installed, of course, on my MacBook here, I've got VS Code and the Docker extension in VS Code, which is just a extension you can get from the App Store or the extension store, or whatever they call it. And the cool thing about this is it interacts with your local running Docker instance, and it actually says, hey, you've got these instances running right now. And by the way, you can just right click and attach to them. So we're going to attach directly to that Chia instance that we've got running with Visual Studio Code. This is really just a fancy way, if you think about in Docker itself, you could hit the CLI, right? Like a remote CLI into it. Think of this as just a much nicer, fancier way, because you're going to be able to scroll through files. You're still going to have your terminal that you can do everything remotely that way. But it's just a lot nicer environment, of course, if it will load, hopefully.
Oh, and it's not.
Yeah, I wonder, let's make sure I don't have another one open. Seems fine. All right, let's close that. Let's just restart it here. We'll stop this. As long as I don't delete, I need to stop. We'll just stop this one, I think. We can stop that one maybe and leave the other one. It's trying. Okay, there we go. It stopped. Now let's try to start it back up again. All right, we're starting. Full node started. Okay, so it looks good there. Let's try to connect again. So back in Visual Studio. Let's see, did that? Yep, so it came back up, and we'll say attach. Here we go. Just
Okay,
gotta
cool. So now we're sitting at the Chia directory. So this is a very standard place to be dropped into, right? Okay. Yeah.
So of course we've got our normal stuff here, and there's your new data layer folder. So if we look in that, we've got a DB, and then we've got our main data layer mainnet SQLite folder. So the interesting thing here, if we look at Chia show, let's just see where we are. So, oh, good, we're already synced again. So we were down for a minute or so, but we're already synced back up. That's good. I don't believe it starts with data layer running. So if you look at Chia start H, we do have the new data option, but for some reason right now, even if you do Chia start all, data does not start. So I've noticed that probably just a bug. Chia start data. All right, data layer is now started. And notice we're listening on a new port, Visual says, that's cool. So now we can do what we were showing earlier. So we're now, if we look at the new commands, let's do Chia data. So this is the new CLI commands that we can look at. Notice we've got create data store, get keys values, get root, get value, subscribes, unsubscribe, update. So it's really, kind of CRUD methods here. You've really got, here's where you would create your initial one. This is where you actually create the data store itself, the singleton for the data store itself. So to do this, let's actually look at the help on that one. And you'll see that we actually need some Mojo, because just like our NFT plot, it's got everything has to cost something, right? Everything's a coin on the network. So notice right here, oh, actually, I'm sorry. This doesn't actually let you set that. It will use a Mojo from your wallet, but you can also set a fee to make that transaction faster if you want. That's what I was confused on that for a second. But anyway, the idea is that you create a data store and you can supply the wallet that you want to create it into, because again, this is going to create a new type of wallet inside your wallet called a DL wallet, data layer wallet, that's going to store that singleton that you're creating. So you can specify the wallet here, the fingerprint if you want. Otherwise, it's going to ask you like most other RPC CLI commands do. You can specify a data port if you want, but that's pretty much, of course, if you leave it blank, it'll just be standard. You can add a fee, like I said, to speed up that initial singleton creation if we're in the middle of a dust storm or something like that. And then of course help. So I did that already. I ended up with a singleton, and that's kind of what you saw in that Twitter feed. If I can go back to my, here we go. Okay, oh yeah, let's look at that. So let's look at get data store, get keys values. So this method, or CLI, again, you pass in the store ID that you want the values for, and the wallet if you wanted. And then it's literally just going to say, okay, here's all the data that I have for that data store ID. And this is all local in your database, remember. So far I've created a data store, which gave me back a singleton for that data store and put that on the blockchain. That cost me 1 Mojo and maybe a fee if I attached it. That created a new wallet in my wallet, a DL wallet that now holds that singleton. And now I can start pushing data into my data store on my local machine. And that, I think, the data layer itself will now take care of hashing that, updating the singleton. That's where I'm not really sure when that singleton, surely it doesn't happen after every update. Maybe you can batch updates. Maybe it happens on a time-based. I really don't know that kind of stuff yet. But at some point, your data that you've committed to your local data store is hashed and verified and put into that singleton, and that singleton gets updated so that anybody else who's subscribed to you knows to update, knows to ask you or anybody else who has it for that latest data. And I think that's where we see here in Chia data subscribe. So there's subscribe and unsubscribe. And notice again, what store do you want to subscribe to? So someone needs to give you their data store ID. I am almost imagining this like a tail. This is what I was saying, kind of just in my mind map brain. A cat, is represented by its tail, so to speak, a token. So it's a big long ID of some sort that represents that cat. So it's that cat. In this case, this is kind of the same thing, although the tail is, it's actually CLVM and Chia list code. But in this case, it's just an ID, I think. But it's kind of the same thing.
That's the way I think about it. It's an identifier. It's like a channel. It's something that there's data that you're interested in interacting with, and it's known by that singular value. It's like a GUID or a UUID, something like that. Yeah,
that's a better way to say it. Yeah, instead of that I think that's a better way to describe it, for sure. So anyway, so if you want to subscribe to someone else, they have to give you their data store ID, which of course is not like a secret. They could, I guess it could be a secret theoretically, but you could publish this out on a website, of course, and tell people to subscribe. You also need to know the IP and the port that you're going to connect to get that data. So when your wallet sees the singleton that you subscribe to is changed, it needs to know how do I go now? Where do I go to get this updated data?
And so this is maybe a pretty crude early form of this, because yeah, if we were going to have a real peer-to-peer network of syncing this data, we would not want to have some singular IP address that we have to know. We would want a way to what's known as gossip for peers, or find other people that would be replicating this data. And I think this is where we had that conversation about this not being necessarily a data durability thing. I kind of view this as it's a way that we can create these pub sub systems, a way to know that there's data, and then between us be able to replicate it and find out about it. And actually Datalayer provides all of those mechanisms by default, syncing to this little SQLite database that would be on the local file system.
Yep, and the cool thing too about it, if you think about it, is it's opt-in, right? So again, we're not storing a bunch of junk data on the chain, and not only that, you only are storing data that you've committed to store, right? If the data is useful to you in some way, then you would sync that data and make use, commit part of your hard drive space that otherwise can be committed to plotting, right? So it's valuable space that you've decided to commit to this data for whatever reason. And the more people
let's talk about that just for a minute, because that was an interesting conversation where maybe we can talk about how this might intersect with other things that we've been discussing, right? So where do you put your Jedi space marmots or whatever, right? Right. So they could go out in IPFS or something like that. Or if you are interested in having the data stored in a data layer, then what you could do is you could say, well, I'm generally interested in NFTs. And so there's an NFT channel. So I'm going to subscribe to the NFT channel. And then what's going to happen is I'm going to get all this data synced to me from whatever IP address that I connect to. So obviously with some scale problems, this is going to work straight out of the box, because whoever is hosting that IP, they're going to get blasted with everybody that's trying to get their Jedi laser cats, whatever, right? So exactly. You talk to this IP address or this swarm, and then all of a sudden you're syncing this data, and now you have a bunch of data locally. So all this data is now, it's stored in your local SQLite database. And so now if you were to create some viewer, the viewer would be talking to this local database or this local interface. So you wouldn't have to reach out somewhere to the internet to bring the data back. That getting the data already happened. That was what data layer syncing is doing. So you have all the data you need, it's here. Now you might have a lot more data than you're interested in. I think that might be kind of one of the tricks here is, you might need to have like only a Space Marmots channel, right? That's the only place it's like Space Marmots go in this channel and that's it. So like if you want the Space Marmots because you bought one of those NFTs and you want to see it, well, then you got to subscribe to the Space Marmots channel. So it might be the kind of thing where you have a lot of different channels that are doing stuff like this. I could see ways forward with this, but like that's how it would work is you would then subscribe to this channel. You have all this syncing. Now the data is local to you, and then your wallet actually can talk to your local file system to find the data. It doesn't need to go externally at all. It's talking locally. It already has the data.
Exactly. Super fast, super scalable, because you don't have to have, Cloudflare that can have 1 million people asking for the image at once, because everybody's asking for the image on the local machine that's already been synced in time, so really cool use cases, at least I think, not for everything, of course, but I think there's certainly some interesting use cases here for sure.
And I think that there's some interesting stuff as far as like how these things might be able to work in the long term. I mean, gosh, if only we were operating with a chain where somebody was really good about peer-to-peer file syncing. I mean, if only we had somebody who really knew how to do that.
Yeah. Yeah, it's
We're just joking. It's Bram Cohen, the creator of BitTorrent, the one who also created Chia, of course. You know, it's like
they pull me out and they pull me back in. You know, like they can't get away from this. But
all
yeah,
right. Well, can we see a few of the command lines
yeah,
interacting with Datalayer? This one's kind of cool. Like I'd really like to see it.
absolutely. Okay, so we're gonna actually do something here. So we will say Chia data H again, and
Yeah, let's do one thing though. Let's do that Open Apple Plus a couple more times, and let's just really make this big because I think we're really going to get to some fun stuff here. There we go. Now it's nice and easy to read.
All right, let me make this a little wider too. Okay, cool. So yeah, so we are going to let's first just see what I've got in there right now. So we can say get keys values, and again to remind us what we're going to do here, all we really have to do is pass in the store. It's going to ask us for the wallet fingerprint and this other stuff if you have multiple wallets. So let's just do that. So we're going to say get keys values, and we're going to pass in the store ID, which actually I have saved here. Let me just do this somewhere up here. Here we go. Yep. So this is my crazy store ID. Let's take that off. And so it's just get keys values, the store. This is my big long Singleton store ID that I created with
right.
that.
So that's that GUID we talked about before.
Yep.
So this is how you'd see it. It's just this long string of character kind of a thing.
So
and
when you run create data store, it's going to generate this for you, return it from that. It's also going to cost you one mojo that goes out on the chain and creates the Singleton, of course. So
and then the other thing we've got here is we've got your fingerprint. Is that right?
That's right. So fingerprint is actually which wallet do you want to talk to? Because remember, these are actually a DL wallet. So it's going to ask you which wallet. If you've got multiple keys configured, then you may want data out of different wallets.
And let's just talk about that for a minute or two here. So wallets and different wallets. So there have been discussions about the different types of wallets and things that are coming, custody from Chia and whatever. So right now, really, a lot of us have had interactions with two kinds of wallets. We have the standard wallet, which is the standard puzzles and everything. And then we have cat wallets. Okay, so cat is a different type of wallet. It's wallet type 6, I believe, if you look in the database. And then the other wallet is wallet type 1. So Datalayer is another type of wallet. And what they're doing here is all the different primitives that we're creating inside of Chia are being differentiated and are being known by these different wallet types. Essentially, what you can think about in the world of Chia and then the terminology that's being used is wallet is a bunch of Chia-less puzzles and primitives that exist to allow you to do these interesting things. And this is where Chia is unlike anything else in the entire world because it allows you to do this kind of stuff. You can define these puzzles, these programs, this Chia-less stuff, and then you can associate wallets with it, and it's extensible. It's like you're creating brand new applications on this base layer, this blockchain, and you can add new stuff to it all the time. So here we go is another example of another thing like the Chia company corporation created. That's an open source thing. It's available for anybody to use. They created this new thing, a new wallet type, and it's interacting with the CoinCept model. They didn't have to upgrade. They didn't have to fork. They didn't have to do anything. It's all just there as the architecture. And this is Web3 in a nutshell, all client. Like nothing is stopping you. You can do whatever you need to. And so this is saying there's a wallet that exists associated with your fingerprint. And so now we're just going to look at some data and some coins that are associated with the wallet.
Yep. So, and I do actually have a few keys installed here. So it is going to ask me, oh, actually, no, I'm sorry. That was my other Docker. So if you did have, you know how you can install multiple keys into the Chia wallet. So if you did have multiple keys, then it's going to ask you, if you don't supply the -F, the fingerprint, it will ask you which one of these keys are you talking about. But anyway, so here we go. So it returned back to us all of the data that it knows about for this specific data store ID. In this case, if you saw from my Twitter, we actually, if you look, I know it's kind of hard to see here, but this is actually one record that I've got highlighted, and this is the second record. But the first record was just that simple cafe food. So notice we've got a hash of the data. We've got the key, which was dead beef. Again, this has to be in hex, so these are all hex characters, and then the value was cafe food. So whatever app is interacting with Datalayer, one of the obvious very first level things it has to do is convert all the data that it wants to put on Datalayer into hex for the API. So that's something to think about. Also, obviously, on the way back out. So if we wanted to actually store text values or anything, we need to convert that to hex, store it, pull it back out, convert it back to whatever values you wanted. And we see that in the second place here. So those were just simple hex values. But in the second record here, I'm actually we get past the hash here, and here's the key, which is a lot longer. And this is actually we the people, the text we the people encoded into hex and stored as the key. And then the value, I was just kind of playing to see how big we could make these. This is actually the First Amendment of the Constitution. So it's actually the text of that hex encoded and stored as the value. And this was just kind of a way to play with that and see how much we can store. But that's kind of, so it's obvious this stuff is in the database. It's got these hashes.
So this, okay, but this data is in, and I think it's cool because we actually have this on the screen. Highlight line 12 there.
Oh, up here.
Yeah.
Yep.
So this data is stored in the Datalayer database, not on the blockchain, in the Datalayer database.
That's right. And in fact, we can go kind of prove that here. Again, that's the new folder that we get here in Datalayer. So, well, just right here. So LS, we've got the new Datalayer mainnet SQLite, and then of course the temp files that are running right now. Now, one thing that I don't know SQLite well enough to know, but actually this is actually a great question for you maybe. Where is my, hold on one second. Let me find my, I had a, oh, that's not, nobody needs to see that. Let's see, this guy right here. Okay, DB browser. Let me move this over to that screen. Okay. So DB browser. So what I was trying to do here, again, like I said, I've got the mappings of the compose file. So I should be able to open this database directly from my machine because I mapped it up to my machine, so to speak.
Yep.
So let's see, mainnet DB. Oh yeah, here. Wait, is that what I did? Hold on, let's go look. So I mapped mainnet data layer to mainnet data layer. Yeah, so we should be seeing in my local here, we should be seeing data layer here. So it's not there. I'm not sure. Oh, you know what? I think I just added that. Like I said, this is all like I'm literally been working on this today. So I think I haven't rebuilt since I added this bit because I was going to try to get into it. But what I did do was I was able to at least copy that up into here. And here's data layer. And what I noticed, so it's only 4K, tiny. Of course, I've only got a tiny bit of data in it, but it doesn't seem like there's anything in it either. So there's no tables, indexes. So I almost think that like there's a flush that I'm missing. Like, is there, because those temp files they do have like the 30, 40K. I'm almost thinking my key values are in those temp files and they need to be flushed.
Yeah, that is what happens. So it's like what's happening with SQLite is the wall file and the .shm file, they hold data for a period of time until it gets flushed and saved out into the main. So yeah, yep. That's definitely what's going on.
I think what we're seeing out. So I'm not sure.
Well, so we probably can't prove that out right now, but that's okay.
That's my next thing is to try to figure out how to flush that and actually look at the database. So I'm kind of interested to see. I did see, if you look in the code, you can at least see the scripts that they're using to create the file, so you can see the tables and the column names, and that's interesting. But yeah, I'd love to actually kind of see.
As far as interacting with data layer, can we put one more set of values in there and just kind of show how that?
Absolutely. So let's. In fact, that was my next thing. Let's actually find an image, right? Let's go for broke here. Let's find an image and.
So what we're gonna, so while you're doing this, I guess I'll spitball what we're gonna have to try and do here for the idea. We're gonna go find some data, some actual image data here. And with that image data, we're gonna have to convert this to hex, or we're gonna have to have it encoded as a certain way that when we put it into the command line, it's going to accept it. And so that means that we need to have this in a particular way, because otherwise it'll complain and say that's not hex encoded. So it has to, the only characters that we can put in as the interface here are any of that 0 to 9, A through F. And if it isn't some of those characters, then it's not going to let us use that data. It'll say invalid hex or something like that. So what we've got to do is we've got to take this image and we have to encode it in hex, and then it'll allow us to store it in data layer. But then if we want to view it later, we'd have to decode it. So we have this little encoding step that we're going to have to go through to actually allow us to make this work.
Yep. So this is where you might definitely come in handy. So what is is there an easy way to, from the command line, convert a binary or just an image to hex, or should I choose like an online?
Yeah, it might just
500K. So this is definitely going to be a fun test. Like online image to hex converter. I don't know. It'd be nice if there's just like an upload button and then an output file to hex converter, maybe. All right. Insert new lines. We don't want new lines. That's fine. All right. There's our Marmot 6, 593 kilobytes. There it is, but that's not what I really want it just without the zeros. So I guess I could.
Oh, wait, there's an option. Use 0x and comma as separator.
Oh, yeah. Cool, cool, cool. Oh, generate. I guess I have to generate it again. Okay. No. Let me just see if we can refresh. So uncheck, uncheck. There we go. Perfect. That's probably massive.
Oh, wait, there's a copy button. Click that copy up. There you go.
Good. Okay. Okay. So let me go back and find one of my my insert commands here. No, that's the store. Get.
Oh, here's something interesting, Josh. So instead of doing all of that, if you don't have anything sensitive, you can type the word history and it'll show you the entire history.
Somebody showed me that the other day. Yeah. Beautiful. Yeah, I don't think I have anything sensitive in here. We're definitely just looking for, here we go. Here's all my tries. Okay, so let's just copy this guy. And then paste that. And so we will put in, oh, what is Marmot?
How about let's use our 8005. That's the fun one. There we go.
Perfect. And our value, of course, is going to be, I need to copy this.
Oh, wait. So I think you made a mistake there because you can't double click stuff on the command line. So I think you just nuked your double quote. Yep. So right after the 5, you need a double quote there.
There we go.
No, you've lost the comma.
No, I see what you're saying. Yep. There we go.
You still lost the comma though.
Jeez. Yep. Boom.
This is just pair programming. This is good stuff.
Yeah, exactly. See, I would have done that 6 or 7 times before. I got it. Okay. So we're going to delete this part and then back to here, copy this guy back to here. Now I should be able to do that.
Yep. Paste.
It might take a minute. Yeah, it's thinking. That's a big file. Well, it's locked up my input, so I think it's.
Well, just give it a second here. It probably will return in shortly.
I may have already screwed it up if I hit the up button or something after that.
Just let it roll.
I wonder if we could store that to text and somehow could we pipe that in? I don't know if we could do that. Or we could make this whole JSON just a text file, right? And then maybe pipe it in as the argument.
Well, you'd need to get it into the exact right spot where value is. I mean, that would definitely be some. It's possible. It's just it's some tricky bash food for sure. Yeah,
I think we're still kind of.
What we might want to do is let's try this real quick while we're waiting for that, just to see if we can set this up a little bit better. Go back to your Marmot picture and you just open it up using preview.
Oh, okay.
Yeah, just double click it. Okay. Now what you can do is if you go to the top of the screen, there's a option in preview and it's called let's see, what is it? Tools, and then there's adjust size. Yeah.
Good. Yep.
And let's make it smaller so we just don't have we don't need a huge image here.
Yep.
Oh, and then use percentage. So you see how there's like it says pixels inch.
Mm-hmm.
Say no, not instead of inches, pick percentage.
There we go.
Yeah, and let's just make this super small.
There we go. 4K. That's not bad. Yeah. Okay,
so now if you close it, no, just close it down. Hit that red X in the upper. Yep, there you go. And then just open it up one more time. It'll auto zoom it to something more reasonable. Oh, look, it pasted in.
Oh, it finally did.
Yeah.
All right. Well, let's just.
Well, likely this is going to fail, but like it's good. Hey, don't scroll up. Don't. No. It's your
Okay,
command is sitting there ready to go. So it's like.
Okay. Okay. And I also need a quote at the very end, if I remember.
No, I think you have a quote. I flashed on the screen for just a briefest instant. Yeah, you're good.
Okay. I still think I'm
missing a quote.
No, it's not. It's not still not responding yet. All right, well, this is 3K now. So while that's thinking some more, I almost think I could, can I just kill this?
Maybe.
Yeah, it's not even letting me kill it. Well, I will just open a new terminal window.
All you should also be able to type the history thing.
Oh, yeah. Oh, is that gonna like freak out?
Oh, with that huge... it might. Yeah, maybe don't do that.
Okay. Okay, let's just encode this one, the smaller one. So we'll go back to this file, the hex converter. I think I had to refresh. Clearly
have a few logistical challenges here to make this production ready.
You know, encoding 500K on the command line, maybe not the best idea. All right, this looks better. So we'll copy that, and I guess I don't. Yeah, this will be fine still. So we'll go find that again, just so I get all this stuff right.
Oh, you know, I don't think that actually made it to your history. You can just type history.
That's yeah, because I obviously would have happened just then too. Okay, cool. So we need this guy.
That's an update though, right?
Oh, Chia update, data store. Yeah, sorry. We need from here on. Make sure and grab that quote and paste. Okay. So now we will do the key, which was our 80085, and the value, which I need to copy one more time. Copy and paste. Nice. Okay. Looks good. Oh no, what did I do?
I think it's just a weird buffer thing. Just hit enter.
Okay.
Oh, no, you need a single trailing quote and enter again. Type a single quote.
Non-hexadecimal. Yeah. Oh, that's weird. Oh my goodness.
Oh, do this. Just hit enter a couple times. There you go.
Okay.
Type history again, and you should be.
Now I have that, but it doesn't look like it has a quote at the end.
Yeah, let's do this. So if you hit down arrow and then hit enter. Okay, type history one more time, and let's just re-grab your command.
Ah, okay, cool. Yeah, there's definitely not a quote there, so we'll put one on there. Whoops. Whoa.
And I think you're gonna have to be careful. Like, don't move your cursor around at all. Just paste and then hit the single quote and then enter.
Okay, so down here, make sure. Okay, paste. Just single quote. Yeah.
Yep.
Okay.
Yep. It's just a weird buffer thing.
Got it. Still got a non-decimal. And at position 5. That looks good. But it's saying way up here even. Insert. This seems fine. Oh, I need a 0x. That's it. So how do I?
You're gonna have to paste this into Notepad or something and text edit.
I think you're right. Okay. Text edit. I just need a new document. Okay.
Oh, and then there's something fun here. If you go to the top of the screen, you can make this thing plain text because it's trying to do it in rich text right now. So I would go up and make that plain text.
Boom. Nice.
And the other thing you can do is Open Apple Plus zooms in here too. So you can zoom up even in this thing and make it bigger.
Very nice. All right. Okay, so added the 0x in the front. We've got we need a single quote at the end. And I think we're good. Copy that. Still doesn't like it.
Maybe it doesn't like the uppercase characters.
Maybe. Is there, I guess there's I know, of course, we could do it easily in code, but truly
I would again just find an online tool just for the sake of going quickly. Just search for to lowercase on web, and I'm sure we could just encode that to lowercase.
I need like a to convert to. There we go. Lowercase, please. Thank you. And paste. Looks great. Copy. Paste. Oh, that was the wrong spot. Down here. Boom. Boom. Still doesn't like it.
I wonder what it doesn't like.
A position 5, non-hexadecimal number. Oh, whoa. So back in here, I mean, I didn't do anything dumb here, right? There's nothing, that's all correct. That is correct. Well, let's just try something silly. I don't know. Let's just get rid of a bunch of this junk. Let's just see if something really simple like that works. Okay, so it doesn't like that at all. It's not our 8005 weirdness, is it? I
don't think so. I mean, that looks like valid. Oh, wait, maybe it doesn't have enough characters. Maybe put it, wait, no, leave that in there, that 8005. Just put a preceding 0 on it. No, not quite. So you want 8, put it, yeah, there you go. Well, not 2, just 1, because I think there's the wrong number of characters in it.
6, right? Okay.
Yeah, because it's pairwise. It's got to be. I think we had 1 too few characters. Try just doing that, and then we can try our.
I'm gonna go back then and get my full text here, and then we'll do just 1 here. Boom. Okay, let's see what that does. Oh, it's thinking.
Success.
Did it? Hello?
Oh, let it go. Let it do its thing.
No, look at that.
Success true.
That took a lot of time, but I guess maybe encoding or something, or maybe it was just the first time. But yeah, so now we should be able to say, oh shoot, Chia data get keys values store. Oh, I don't have my store. Let me go copy it from here. Boom. Look at all that. So there is our new key.
Cool. All right. Datalayer, a space varmint encoded in Datalayer.
With a laser light beam. What do you call those swords?
Jedi lightsaber.
I don't play Space Wars very much.
So the idea here would be you've got your local store of data, right? So you're busy syncing away. And then what happens is there was this new update on chain. So if you were subscribed, because I think maybe we should show that real quick, show the command for subscribe.
Yep.
Yeah, so this is where we can put that GUID in again. So if we wanted to go to a different machine, now that would have really made this this demo really neat, would be if I were to have the same Docker setup going, and then I say I want to subscribe to it, and all of a sudden, bam, there's the space marmot picture. And now if we were to add a plugin to the Chia full node, now, man, we'd be off to the races, because then we could say, well, whenever I want to show something, I can try to look inside a data layer. I could look for the right channel, and then I could pluck the data right off my local file system. And okay, I think, you know, I need to walk something back. Fanciful? I think not. Cool stuff. cool stuff here. You know, it's not exactly, I didn't have as deep of an understanding of data layer back when we were first talking about it. Definitely what's on chain, you know, is
Yeah.
different. And the whole idea that it's replicating in the background is something that is happening. And so this is really cool tech, really cool technology from Chia.
Well, and I think that's too. That's why I said I think when we were talking, we were literally talking about two different things. You're thinking about the blockchain itself, what goes with the singleton and all of that. And of course, we don't store data there. That's not where the brand's already said that. Don't do that. You know, that's not where we store data. But I'm thinking more of, okay, the other thing, and then you were thinking, well, that's reference data. So yeah, I think it's all coming together now. Like I said, I'm going from the top down, and you're going from the bottom up, and I think we've met in the middle finally on this one. So
yeah, and this is just really awesome tech. Really excited. Josh and I could get together and talk about data layer today. This was fun to geek out on some new tech today.
yeah, definitely.